what to do. Okay, the copper 2 sulfate, pentahydrate lab. Okay, so when we see copper 2 sulfate pentahydrate, this is kind of what it looks like. CuSO4.5H2Os. That's not a mystery. We know that that's what it's supposed to be. That's the actual formula. We also know, because we've done this before, that this is 36.1% water. Okay, how do I know that? Because I've done the percent of water in this copper 2 sulfate. Now we're going to do it experimentally. Okay, this is the actual yield. What I mean by actual yield is if I take the CuSO4, 114, 64, 32, 16, 64, 32, 64, 160, and then the 5 18s for the 5 waters, and I get 90 grams for the water and 160 grams for the CuSO4, we know that this whole thing is going to weigh 250 grams, so that's what this whole thing weighs. You following me? And then this is 90 grams divided by 250 grams times 100, which is going to give me the percent that's water. The water is the part, 90, 250 is the whole thing, and I get 36.1% water. That's what I mean by theoretical yield. This is not the experiment. This is what we know is supposed to happen. Okay? All right, now, you are going to get a container, and in the container there's going to be only 3 little things. There's going to be this lovely dish, okay, an evaporating dish, porcelain, just a ceramic dish. You're going to have a glass rod, and you're going to have these tongs because this porcelain dish is going to get really hot. Okay? All right. The first thing you're going to do is you're going to measure the mass of your evaporating dish. Okay, so you're going to walk over to the back tables. You're going to measure the mass of your evaporating dish. And I'm going to make numbers up so that you can see how it works. These are not the numbers you're going to get. I'm just making up numbers. Okay? So we're going to say that this evaporating dish weighs 54 grams. Okay? Then you're going to take the dish. You're going to bring it over to me. And I'm going to take, and I'm going to give you some copper 2 sulfate. So this is copper 2 sulfate. See, copper 2 sulfate. It's a hydrated salt, and it's actually really pretty. Looks like that. Okay? What? Looks like meth? Only looks like meth because of Breaking Bad, but it's a blue salt. Why is it blue? The copper, yes, the copper. So remember, copper is a transition metal in the center of the periodic table, and when they are in compounds, they will form colored ions. And that's why we have this blue copper 2 sulfate, okay? So I'm going to give you a little tiny bit of it, not a lot. You're going to be like, what? Why are you giving me so little? And you'll say, oh, thank God you gave me so little. Because you're going to heat it up. So here's your copper 2 sulfate. It's in the dish. You're going to take it back to your lab table, and you're going to measure the mass of your evaporating dish, ED, evaporating dish, and the hydrated salt. This is hydrated, which means it's the copper 2 sulfate with the 5 waters attached to it. Do you understand? Okay. So really, this hydrated salt is the CuSO4 and the H2O. So right now, what I have here is I have the dish, I have the salt, and I have the water. And I'm going to get a mass. So I walk it over to my lab table, I measure it, I get a mass, and it's 146 grams. Again, I'm making these numbers up. You with me? Okay. Now, we want to figure out how much water is in this dish. How are we going to do that? We got to heat it up because the water will evaporate or vaporize. And when it does, the reason why we use the copper 2 sulfate in here is because this copper 2 sulfate is going to change to an ash gray color. It's going to be it's going to look like cigarette ashes, or when you burn wood in a fireplace, that ashy, white ashy color. So once you start heating this up, the water is going to start coming off of there. There's a hot plate on your lab tables. Okay? So there's a balance and there's a hot plate. Now the water is going to make this whole thing kind of like clump together. So every once in a while, break it apart and spread this out with your glass stirring rod so that you make sure that it is all white, ashy, like a grayish ash color. Okay? So now we are going to get this is going to be white. Let's pretend it's white because I'm not heating it up right now. So it's white now. And there's a white ash in here. And so what do I have now when everything is said and done? What's in this dish? ED, evaporating dish, and the copper 2 sulfate, which is called the anhydrate. Okay? An means without, hydrate water. Anhydrate salt. Okay? And then, here's the thing. How are you going to know that all the water is gone? It turns that whitish ash color. However, sometimes, like I said, it clumps up a little bit. You have to make sure all that water is gone. So you're going to heat it up. You're going to put it on your lab table. So let's say that this is on the hot plate right now. Use these because this is going to get hot. Okay. You're going to take this. You're going to put it on the lab table. You're going to let it cool off. Then you're going to put it back onto the balance. You're going to weigh it. Then you're going to heat it up a second time. You're going to say, hey, all the water is gone. You're going to heat it up a second time. You're going to put it on the lab table. You're going to let it cool off. You're going to weigh it. If the weight doesn't go down anymore, you know that all the water is gone. Okay? Because just because we're using the blue salt and it turns colors, sometimes you don't use a blue salt and you have to make sure all that water is gone. So you're going to heat it at least twice. If it does go down again, if let's say the first time you measure it you get 100 and the second time you measure it you get 95, then you have to do it a third time, make sure it stays at 95. Make sure that that weight does not go down anymore. Once we know that the weight of the mass of this is not decreasing anymore, we can be assured that no more water is coming out. Okay? Alright, that's why this lab takes a while. So now we have our evaporating dish, ED, and our anhydrous salt, and it weighs 112.88. I made sure that all the water was gone. Now I'm done. I have all of my data, and now I can figure out what the percent of water was in the copper 2 sulfate that was in my evaporating dish. So what do I need to find percent of water? Percent of water, I'm going to need the part that was water, and I'm going to need the whole thing, times 100. How am I going to find out how much water I had, given these three numbers? Go ahead, Alex.
First you have to subtract the evaporating dish from both.
Okay, so you could take this evaporating dish, hydrated salt, and copper 2 sulfate hydrate, and you could subtract these two. What is that going to give us?
Copper 2 sulfate and water.
Right, exactly. So it's going to give us the hydrate. So the hydrate means it's the copper 2 sulfate and the water together. If I subtract these two, now let's get a calculator. 146 minus 54. I'm going to get 92 grams for the CuSO4 5H2Os. Okay? And this CuSO4, how am I going to get that? How am I going to find out just how much just the salt weighs? This is the dish and the salt, no water. This is the dish. How can I figure out how much the salt weighs? Subtract these two guys. So what's 112.88 minus 54? That's going to be 58.88. So this is just the CuSO4. How can I figure out how much the water weighs? Where is everybody today? There's a lot of people out. Anyway, how can I figure out how much the water weighs? Go ahead, Alex.
Subtract the anhydrate from the hydrate.
Okay, we're going to take the hydrate and subtract the anhydrate. Or we could take the evaporating dish, the hydrated salt, and subtract the evaporating dish and the anhydrous salt. So you could either take these two, or you could take these two. Either one is going to give you the same answer. And so the water is going to weigh 33.12 grams. Okay, so now we have to figure out the percent of water. What's the part that was water? Right, 33. You guys awake out there? 33.12 grams. What does the whole thing weigh? 92 grams. A lot of people, and the reason why I'm going over this is a lot of people will say the whole thing weighs 146. No, that's the evaporating dish. We don't care about the evaporating dish. Times 100. And so if we do 33.12 divided by 92, oh, look at that. We're going to get 36% water. What should I get? 36% water. What did I get? 36% water. Now that's not saying you're going to get 36% water. You might get 37% water. You might get 35% water, depending on how good or how well you do the experiment. Okay? All right, now, I want you to also prove that you are in a 1:5 ratio, a mole ratio. Okay? And what I mean by that is you have CuSO4 and you have DOT and you have H2O. I want you to prove that this number and this number are 1 and 5. Okay? These numbers represent moles. It's a mole ratio. So just like we did with empirical formulas, you're going to prove it using your numbers. So here we have 55.88 grams of copper 2 sulfate. 55.88 grams of copper 2 sulfate. And I had 33.12 grams of water. How can I change those into a mole ratio? Go ahead. Yeah, baby. Divide by the gram formula mass. So copper 2 sulfate, we looked here, that's 160 grams. Right? So that's the gram formula mass for the CuSO4. 160 grams per mole. That's going to give us moles of CuSO4. So we're going to do that. We're going to take 55.88 divided by 160, and I'm going to get 0.349 moles of CuSO4. And then we're going to do the same thing for the water here. Let's turn this off. So 33.12 divided by 18 grams per mole. 33, ooh, I don't have enough light now for my calculator to work. 33.12 divided by 18. I'm going to get 1.84 moles of water. Okay? So these are my numbers now. 0.349 CuSO4 dot 1.84 H2O. Well, we want these to be, in lowest whole number ratio. So how do I do that? You got it. 0.349, 0.349, and we're going to get 1 and 5. Yay! And that proves that we have a 1 to 5 ratio. Okay? Alright, so backing up. You're going to get yourself a little box. I have the lab all printed up for you. Okay? You're going to get yourself a box. You're going to measure your evaporating dish. That's this thing. You're going to come back up to me. I'm going to give you some copper 2 sulfate. You're going to start heating it. Yes, you need to wear goggles. Okay? You're going to start heating it up. You're going to heat it up, heat it up, heat it up. Oh, before you do that, measure the mass of the evaporating dish and the hydrated salt. Okay, then you're going to heat it up, heat it up, heat it up, cool it off. Heat it up, heat it up, heat it up, cool it off. If the mass doesn't change, then you measure your last number, which is going to be this number. Now you've got these 3 numbers. Now you can do the math. Okay? Does that help solidify it in your brain? Everybody good? All right. Let me shut this off.